Kia ora koutou, Reese from QuickSense here, and today we're looking at composite functions. Now, one of the first skills with functions generally is the notation we have at the top. So we're evaluating if gh of x is equal to, etc. And then in the brackets it's giving us, well, what we want x, what is our input? So enter this function, gh, at minus 4, we're putting in minus 4 as x, and what do we get out? Well, we get out minus 4 squared plus minus 4 plus 2 equal to 16 minus 4 plus 2, which is equal to 14. In this next question, we're really going to have to grapple with composite functions. So here we have f of x. We're asked to evaluate something in terms of g of x, but what we're given is f and g of x. And the best way to think about this to begin with is I need to isolate that g of x. So I can write that middle function, composite function, as f of g of x. Right? So we're doing a little bit of mapping from that to that. Okay, so that's the idea there, to pull almost that g of x out of f of g of x. So what does that look like? Well, f of g of x is x squared plus 6x plus 9. And what I notice, right, is that 9 is a power of 3, right, 3 times 3, and 2 lots of 3 are 6. So I can write this as x plus 3 squared. Right, and we can see this mapping here. Yeah, we can see that mapping. So what does that allow us to do? It allows us to say that g of x here, well, that is x plus 3. Okay, and if I were to put this back into that, right, we would see that f, right, we have this train almost. What does that allow me to do? Well, it allows me to input negative 9. Negative 9 plus 3, well, that's equal to negative 6. So the move from here, thinking of it in terms of f of g of x, where the input is g of x, in order to isolate that g of x and arrive at minus 6.